Alright, hello everyone. So in this lab today, we'll be going over how to send commands from the computer to the Arduino using hardware serial. So in the previous lab, we did see how we can send information from the Arduino to the laptop when we were sending various temperature measurements, accelerometer, and stuff like that. But we never covered how we can go the other way around from the computer to the Arduino. This is actually a little more complicated because we need to be able to process those commands on the Arduino and turn them into meaningful information if we want anything to actually happen when we send the information to the Arduino. As we can see here, this is a simple circuit which we will be using to demonstrate our interfacing with the Arduino through hardware serial. We have 3 LEDs here and we have 3 resistors. They're a very simple circuit. It just goes from a digital pin to the resistor to the LED to ground. Each LED is connected to a different digital pin, so the lowest one here is connected to digital pin 7, the next one's 8, and the final one up here is digital pin 9. We did this because it'll make it easier for interfacing with our commands later on. As a quick demonstration of what it can do is I will send a key here, and the lighting blinking stopped. Ones that we're currently on are stay on, and the 9th LED at the top here is off. Alright, now we'll go to the code to see this actually happen. Alright, now we'll move on to the code section so that the Arduino can actually process commands that we're going to send to it over the serial monitor. So the code for this is actually pretty simple. It's very repetitive too. It's the same thing a couple of times. So basically, all we need to do is initialize 2 global variables. These are going to keep track of if we are in the LED show mode, which is what we demonstrated earlier. And then the second variable, the current pin, is what pin is currently being lit up in that show. Then we need to go to setup. In setup, we need to begin serial connection with the computer, so at a baud rate of 9600, and then set the 3 pins that are connected to the LEDs to output 7, 8, and 9, and then wait for the serial monitor to begin. So this while not serial will make sure that we don't enter the loop until the hardware serial connection is actually made. Now inside of loop, we need to check to see if serial is available. So serial.available returns true when there are bytes to be read from the serial monitor. And a character, so an individual character like A, B, C, D, is exactly equal to 1 byte in size. So that means whenever there's a character that we need to read, we can read it. So we will only enter this loop when there's a character to be read. So we go to our loop here, if serial.available, and if it is, we need to check what that letter is. So we're going to use .peek here. So serial.peek returns the character that's in the serial buffer, but does not remove it from the serial buffer. So we're using that to see what it is before we remove it. This is just for practice, and you could easily get away with writing this code without it. It's just to demonstrate how it works. So serial.peek return a character, and we want to see if it's a new line or a carriage return. If it is, then we're going to take it and we're just going to simply discard it because it's not really useful for us to see a carriage return or new line. And when you open your serial monitor, sometimes it'll, depending on your options, output a new line or a carriage return at the end of your command. So this just makes it so that no matter what you choose, we're just going to throw away that information and it won't bog down the rest of our program. Then we're going to take the value, so this is outside of that if statement, but within the available. So that means if the character was not a new line or a carriage return, then we're going to take it as an integer by parsing the character into an integer. So this is a simple way of turning a character into an integer, and what we want to be interacting with is the digital pins on the Arduino. So it makes sense that we'd want to turn in the character that's sent from the serial monitor into an integer. So now that we have our integer, we're going to use a switch statement. So a switch statement switches between various cases that are defined below depending on the value of the thing within the parentheses. So val here corresponds to the val up here that we used to parse our integer. So depending on the integer, we're going to run different blocks of code. So if the number is 7, we're going to print to the serial monitor that LED at pin 7 was toggled, and then toggle the pin. We'll go over this function below, it's very simple. And then we need to write break, because if there's no break at the end of a case statement, it'll continue to execute all the other cases that are below it. This break makes sure that only this section is executed. We do the same thing for 8 and 9, and then we have another case called 0, which is for the LED show, which is the blinking show we had before. If we send that, then we have to toggle LED show, so we set it equal to the opposite of LED show, which means that if it was on, it becomes off, if it was off, it becomes on, and then we set the current pin to be 7. So the first pin that will be executed in the sequence will be 7. And then we also have a default case where if we send something that isn't a 7, 8, or a 9, then it'll print a help menu and then tell us what we can do. So 7 toggle LED at node 7, 8 toggle LED at node 8, blah, 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 blah. So now we have to write our little case for if the LED show is true. So if it's true, we toggle the LED at the current pin, increase the current pin, and delay for 100 milliseconds. And we also need to make sure that the current pin does not get greater than 9, because if it does, then we could be turning on pins that don't have anything to do with the LED, and then we won't see anything, so that's kind of pointless. So we just make sure to reset it to 7. Now the function LED for the toggling is very simple. It just takes the integer pin number and digital writes to that number the opposite of the digital read of that number. So digital read will return a 1 or a 0, depending on if that pin is high or low. So if it's high, we will read high, we set it to low, and then we write low. This will make sure that the LED is always the opposite of what it was before. Now that we've gone over the code, we'll upload it to our Arduino and give a little demonstration of what it looks like. Alright, now that we've both written our code and assembled our hardware, it's time to demonstrate what happens as we enter commands into our serial monitor. So I have the serial monitor pulled up on my computer with my cursor in the text field, and so I'm going to type numbers 7, 8, 9, and 0, and then I'll hit enter, and it'll send the command to the Arduino. So let's try turning on LED 7. As you can see, LED 7 has been toggled. The serial window, in fact, also says LED 7 has been toggled. Press it again, it turns off. See the same thing for 8 and for 9. And you can also have them on in different patterns. You can have 8 and 9 on, or all of them, or whatever you want to do. So now we're going to turn them all off. And we're going to try the LED light show. As you can see, it started, and now it will run until we stop it. So it's just blinking all the LEDs. We send a 0 again. It stopped it, they stopped blinking. Whatever was on before stays on, and we can just turn them off. Simple as that. Alright everyone, thank you for watching this video, and we hope you enjoyed it. We can learn something from it. If you have any recommendations, make sure to leave them in the comments below, and don't forget to like and subscribe. Thank you.